This lecture is on identifying constitutional isomers and stereoisomers. Isomers have the same molecular formula and molar mass. The types studied in organic chemistry are 1. Constitutional isomers, 2. Stereoisomers. Constitutional isomers have the same molecular formula but differ in connectivities along the parent chain or parent ring. The example of two constitutional isomers whose molecular formula is C4H10 are N-butane and 2-methylpropane. Stereoisomers have the same molecular formula and same connectivities along the parent chain or parent ring, but differ in spatial arrangement. The most common is cis-trans isomers. Cis isomers have the lower atom's mass both pointing down or up, and thus adjacent along the double bond, and trans isomers have the lower mass atoms across or opposite one another on opposite ends of the double bond. The examples shown below are two stereoisomers whose molecular formula is C4H8, and they are trans-butene and cis-butene. The best way to learn how to identify the relationship is to look at each pair of substances and take these hints into consideration. 1. Are the two substances similar in chain length or ring size? If no, they are not identical or stereoisomers, but could still be constitutional isomers. If yes, it is possible they are isomers. 2. If you answered no to question 1, ask yourself, does the two substances have the same molecular formula? If yes, the pair could still be constitutional isomers. Follow-up question, do they have the same location for all substituents? If yes, they are identical, and if no, they are constitutional or structural isomers. If no, the pair are not isomers. 3. If you answered yes to question 1, then answer these questions. Does the molecule have a chiral center or a CC double bond? And if yes, the additional questions are A. Are they enantiomers to each other? If yes, then they are stereoisomers in relation. B. Are the pair substances with the CC double bond on the same location and position? And if so, they are identical. If it is cis and trans in spatial arrangement, then they are stereoisomers. 4. If you answered yes to question 1, then answer these additional questions. Does the molecule have a chiral center or a CC double bond? And if no, then the additional question is, are the substituents in the same location and have the same molecular formula? And if yes, they are identical. If the substituents are in different locations and lead to the same molecular formula, then they are constitutional or structural isomers to each other. Questions 1 to 3 ask, for each pair of substances, what is the relationship between them? Are they identical, structural isomers, stereoisomers, or not isomers? 1A are not isomers because the left structure has a molecular formula of C4H8 and the right structure has a molecular formula of C4H10. Since the pair are not identical in structure or molecular formula, it is not an isomer. 1B are identical because both structures have the same molecular formula of C3H4 and positions of the double bond and triple bond are identical on carbons 1 and 3. 1C are stereoisomers because both substances are 2-pentene, but the left structure is a trans isomer and the right structure is a cis isomer. Thus, the relationship is a stereoisomer. 1D are structural isomers because both substances have the same molecular formula of C4H9Cl, but the left one is T-butyl chloride and the right one is 2-chlorobutane, and differ in structural connectivity, thus they are structural isomers. 2A are structural isomers because both substances are methylpentanes, but the methyl group is connected to a different carbon atom. The left one is on carbon 3 and the right one is on carbon 2, thus structural isomers. 2B are structural isomers because both of them have the same molecular formula of C4H6, but structurally differ because the left one is a cycloalkene and the right one is an alkyne, thus structural isomers. 2C are not isomers because both substances have different molecular formulas. The left structure is C5H6 and the right structure is C5H8, thus it is not an isomer. 2D are structural isomers because both substances are alkenes, but since the left structure is an internal alkene and the right structure is a terminal alkene, a stereoisomer is not possible, but instead are structural isomers. 3A are identical because both substances are similar because the OH and F substituents are in the same location on carbons 2 and 3 respectively, thus identical structures. 3B are structural isomers because both of them are dimethyl cyclobutanes but differ in connectivity. The left one is 1,2 dimethyl cyclobutane and the right one is 1,1 dimethyl cyclobutane, thus structural isomers. 3C are identical because both of them are both 3-hexyne but projected differently and thus identical structures. 3D are structural isomers because both of them have the same molecular formula of C6H14 but differ in both the parent chain and substituents location. The left one is 2-methylpentane and the right one is 2,3-dimethylbutane and thus structural isomers. Here is a review exercise for you to work on. For each pair of substances, what is the relationship between them? Are they identical, structural isomers, stereoisomers, or not isomers? See the structure pairs for A through D. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.